In this video, we present handle flags, a new technique for pen-based interfaces. Handle flags provide an efficient mechanism to specify selections and perform commands in inking applications where the default mode would interpret pen input as ink. Handle flags are localized and do not require the use of any supplementary buttons. Each handle flag represents one possible selection. When the pen hovers over an ink stroke, a handle flag representing the associated selection fades in. For demonstration, the cursor is rendered as an outline when the pen is above the display surface. The handle shows the thumbnail image of the selection which it represents. When the pen moves away from the handle flag fades out. Clicking on a handle activates a contextual pop-up menu, which can be used to perform commands on the associated selection. Here we edit the color of ink. A handle flag consists of a handle and a line connecting it to its associated ink stroke, hence the name handle flag. The purpose of the line is to create an offset between the initial pen location and handle, which prevents users from clicking on a handle when they want to add ink. This allows for a seamless but explicit transition between input and command. The user in this video is left-handed, and so the handles are offset down and to the right to prevent occlusion. For right-handed users, handles are offset down and to the left. When potential ink selections overlap, a layout algorithm is used to ensure that their associated handle flags do not occlude one another. This allows users to easily access ink strokes, which would otherwise be difficult to select with traditional methods, such as lassoing. In many scenarios, users will want to select and manipulate an object which consists of multiple ink strokes, such as a word or a diagram. To provide the system with an understanding of such high-level structures, we implicitly group ink strokes based on their spatial proximity. Handle flags are then displayed for each of these groups so that the user can access these potential selections. Users can still access the individual strokes which make up higher-level groups. Handle flags for such groups are revealed below what can be considered the root-level handle flag when the user hovers over it. This allows users to narrow down the scope of their selection when desired. Higher-level structures are similarly accessed above the root-level handle flag. In addition to navigating through the handle flag hierarchy, we have also explored an integrated tapping mechanism to cycle through possible selections. An icon appears in the top left corner of the root handle flag, which the user can tap. When the desired selection is highlighted, the user can tap on the handle flag to activate the pop-up menu. If the implicit grouping fails, or the user wishes to select a set of unrelated strokes, then the desired selection may not have an associated handle flag. We provide two mechanisms for performing such selections. First, users can create compound selections using 3 selection commands in the handle flag pop-up menu. The new selection command will begin a new selection scope. The add selection command will add to the current selection scope. The deselect command will remove a selection from the scope. A bounding box is displayed around the current selection with a handle on its border. If a command is executed from this handle, a group is created from the selection so that it will subsequently be available from the handle flag. The lower level selections are still available through the handle flag hierarchy. This gives the user the ability to work with a group and its subcomponents. The other method of creating new selections is to use a traditional lasso tool, which in some cases may be faster than building up a compound selection. To provide localized access to the lasso tool, an icon fades into each handle flag after a dwell timeout. Once clicking on the icon, the user can lasso the selection. Adding the lasso icon to the handle flags allows users to first check if the associated handle flag is available. When it is not, they can resort to using the lasso. We evaluated handle flags in 2 experiments. The first experiment was performed in a controlled abstract environment where users selected a set of highlighted objects from a grid. In the second experiment, users selected objects from actual sketches, which were made using tablet PCs. In both experiments, we found handle flags to offer significant advantages over traditional lassoing techniques. We believe handle flags are a promising technique for use within inking applications, allowing for efficient and flexible selections.